Hello guys, welcome to our channel. Let's take this opportunity to solve this question, and before we start I would like to request you to subscribe to our channel. You can also drop a comment and also like this video. Let's start. A particle moves in a straight line such that its displacement s meters from a given point is s is equal to t power 3 minus 6t squared plus 2t plus 3, where t is time in seconds. Find part A, the displacement of the particle at t is equal to 3. Part B, the velocity of the particle where t is equal to 4. Part C, the value of t when the particle is momentarily at rest. Finally, part D, the acceleration of the particle when t is equal to 4. So let's start with part A. We are told to find the distance of the displacement of the particle at t is equal to 3. So here we are just going to substitute t with 3. So it's going to be 3 power 3 minus 6 into 3 power 2 plus 2 into 3 plus 3. So from our calculator we are going to have 3 power 3 minus 6 into 3 power 2 plus 2 into 3 plus 3 is equal to, the answer is negative 18, as you can see. So negative 18. So this negative, we are going to ignore it because it shows that the particle was moving in an opposite direction. So therefore the answer is going to be 18 meters. So from there, let's go to part B, the velocity of the particle when it is equal to 4. Velocity, we are having the displacement function. So SVA, we are at S, we need to go to V. So here we are going to differentiate. So V is going to be obtained by differentiating S with respect to t. So if you differentiate t power 3, it is going to be 3t squared minus, this is 2 times 6, 12t plus 2t, that is 2. That is the velocity function. So we are going to just substitute t with 4. So 3 into 4 squared minus 12 into 4 plus 2. The answer is going to be, this is 4 squared is 16 times 3, which is 48 minus 12 times 4, this is 48 plus 2. Therefore 48 minus 48 is 0 plus 2. So the answer is going to be 2 meters per second. That's the answer for part B. Part B, the value of t when the particle is momentarily at rest. So here, when the particle is momentarily at rest, velocity must be equal to 0. So we are going to take the velocity function, which is v is equal to 3t squared minus 12t plus 2. So here, when the particle is momentarily at rest, velocity is equal to 0. So we are going to equate 0 is equal to 3t squared minus 12t plus 2. So we are going to use the quadratic formula to solve for the value of t. So t is going to be negative b plus minus square root of b squared minus 4ac all over 2a. So for this case, our b is negative, so it's going to be negative into negative 12 plus minus b squared is negative 12 squared minus 4 times a, which is 3, times c, which is 2, all over 2 times a, but a is 3. So from there we are going to have this is, so t is going to be negative times negative positive, so positive 12 plus minus from our calculator, negative 12 squared minus 4 times 3 times 2, it is 120. So the square root of 120 is going to be 10.55. So we are going to have 10.95 44 5115 all over 2a, which is 6. This one 2 times 3 6. From there, therefore t is going to be, we take our answer plus 12 then divide by 6. The answer is going to be 3.8 3.825 3.826 to 4 significant figures, or 12 minus 10.95 9544 5115. Then we divide by 6. The answer is going to be 0.1743 seconds, and this one is in 4 significant figures. So that's the answer. Finally, part D, the acceleration of the particle when t is equal to 4. So acceleration is equal to b, is going to be, dv over dt, whereby we are going to integrate this velocity function. So it's going to be 6t minus 12. So we are going to say when t is equal to 4, velocity is going to be 6 into 4 minus 12. So 6 times 4, it is 24 minus 12. Therefore, the answer is 12 meters per second square. And that is the end of this question. Starting from part A, the answer is 18 meters. We ignore the negative because the particle was moving in the opposite direction. Part B, 2 meters per second. Part C, the answer is t is equal to 3.826 or 1.743 seconds to 4 significant figures. Part D, the answer is 12 meters per second square. Thank you very much, guys, for your participation.